Hello everyone, welcome back to Math with Amala. Here we are dealing with the part 10 of grade 10, chapter 1, real numbers. So far we have discussed some examples up to 4 and we have discussed the theorems 1.2, 1.3 regarding the fundamental theorem of arithmetic and also some important theorems which are needed for the upcoming theorems proofs. In the previous video we have discussed how root 2 is irrational. Now the example number 5 is discussing about how root 3 is irrational. In order to prove this, we can assume on the contrary that root 3 is rational, not irrational. Root 3 is rational. Then at last we will arrive at a conclusion that this root 3 is actually irrational because our assumption is wrong. Okay. Since root 3 is rational by our assumption, we can take some a and b where b not equal to 0 as root 3 equal to a by b. Let us suppose that a and b are having no common factors other than 1. You can write the no common factors other than 1, which means you can write simply like b into root 3 is equal to a from the previous equation. After squaring, you will get 3b square is equal to a square. By theorem 1.2, we have that a is divisible by 3, which means a can be written like 3 into some number, or a is a multiple of some number. So let's take that number as c, then a is equal to 3 into c. Now put this a in the previous equation, you will get 3b square minus 9c square implies b square is equal to 3c square. Then now by theorem 1.2, again we can apply that theorem for b. You will get b is divisible by 3. Okay, b is divisible by 3 means you can give a comma b have at least 3 as a common factor. Here it says like a and b have at least 3 as a common factor other than 1. At the beginning of the solution, we were having a and b as co-primes, which means they were not having any other common factors other than 1. But now we have one more common factor, 3. So this is a contradiction to the fact that root 3 is rational. So we can say that root 3 is irrational. In grade 9, we have already discussed about the irrational addition, subtraction, multiplication and the division or the quotient format. The next example deals with the irrational operations. Okay, we will be having some operations which are done on irrational numbers and we will be proving that they are irrational actually even after the operation. So example number 6, show that 5 minus root 3 is irrational. To give the solution, we can start like on the contrary, assume that 5 minus root 3 is rational. Since it is rational, since it is a rational number, we can have two numbers a and b such that 5 minus root 3 equal to a by b where b not equal to 0. Then 5 minus a by b equal to root 3. Root 3 equal to 5 minus a by b. That is 5b minus a whole divided by b. Actually this is a rational number. Root 3 is a rational also. A and b are some integers and we have 5b minus a by b as a rational. So this is a contradiction to the fact that root 3 is irrational. Here we have got root 3 as a rational number. Hence we can say our assumption is incorrect. That is 5 minus root 3 is rational. That assumption is incorrect. We can say it is irrational. Example number 7. 3 into root 3 is irrational. If we proceed like this, you can say as the same method that we have applied for the previous examples, the solution can start with on the contrary. Assume that 3 into root 2 is rational. Here we will get two numbers a and b such that 3 root 2 equal to a by b, root 2 equal to a by 3b, which is a rational, but root 2 is an irrational already. This contradicts root 2 is irrational. Thus the assumption that 3 root 2 is rational is incorrect. We can say 3 root 2 is irrational. Thank you all for watching the video. Please be stay tuned for the last part of this chapter.